All right, we good to go. We're good to go. All right. So preparing for the final. Got a little QR code for you guys to scan. 1 second, I made it a little too big. All right. So this is all the stuff that we're gonna go over today. I'm gonna leave that up for a minute. You guys can grab that in the meantime. All right. If you guys want to take a look at some of the problems and try it, go ahead. All right, bear with me 1 second. Just got to grab something. All right, let's jump into it. All right. See what we getting into today. Might look a little familiar to some. All right. Well, let's try it again. So question one, we're given a function, f of x is equal to 3x squared plus 2x minus 4, and we want to find f of negative 4. 1 second. I don't like that little okay box there. Right? So anyway, we want to find f of negative 4. So what am I going to do? I'm going to plug in, right, these values over here, right? So I have f of x is equal to 3x squared plus 2x minus 4. Everywhere you have an x, you're going to plug in, right, that negative 4. So this is going to be 3 times the negative 4 squared plus 2 times negative 4 and then minus 4, right? After that, basic math, right? We do our exponents first, then we multiply, then we add all that good stuff together, right? So what's negative 4 squared? 16. Very good. So I have 3 times 16, right? And what's, oh no, I'll do that next. 2 times negative 4 minus 4. Now I want to do my multiplication, right? So help me out. What's 3 times 16? 40? 48. That sounds good. All right. A little bit harder. What's 2 times negative 4? Negative 8. Now we're talking, right? And then minus 4. And then you can just go left to right. 48 minus 8, that's about 40. Minus 4. That's going to give me like what? 36. Not bad, right? Easy, right? All right. Questions on this, anybody? Y'all good with this topic for the final? All right, we're going to give you some function. I don't know what the function going to look like. And we're going to ask you to plug in a number, a whole number, right? And that's it. All right. Let's take a look. What else we got? Oh, nice. Our upload is done. Or download is done. Let me say it like that. All right, this next question, question 2, is the instructions for it tell you to factor completely. All right. So what that could mean is that there's a multiple type of factor that could be done here. So I want like the complete factor. All right. Let me give y'all a minute to try that while I do something real quick on my end. Doo, doo, doo. Where did I keep that? Trying to kill like 20 birds with one stone. So what did we come up with? What did we do? Talk to me. What do you think? Very good. 2x to the third, right? And then it's like you're dividing each one by 2x to the third, right? So what's left over? Very good. 9y squared. Very good. All right. Any questions on how we did that? Or is that clear? All right. What's the next step after this? It's a perfect square, right? So give me the answer that's gonna come out of that. I'll give you a hint. 5x squared, good. minus 3y. And what else? 5x squared minus plus 3y, right? One is a minus, one is a plus, right? So this is called the difference of two perfect squares. So I want to break them apart, one with a plus, one with a minus, and then that's it. So this would be my final answer right here. Questions on that, anybody? All right. If anybody has questions online, y'all can talk or y'all can type it. I will be able to hear you. Okay. That's the wrong thing. That's the wrong thing. Oh, it is the right thing. All right. Under the same instructional title, which is factor completely, right? You're going to have another question that looks like this. All right. So what you have to do here is you have to factor completely as well. All right. I'm gonna leave that up, let you guys try that for a sec while I click a few buttons on my end. Okay. Sec. We're back at it. All right, so what should I do first? Good, but before that, starts with a G. Grouping, right? So I want to group these together, right? I have a left-hand group and a right-hand group. In my left-hand group, which is 2a plus ab, what do I do now? Factor out the right. So I'm factoring out a. Now remember, when I factor out a, it's like I'm dividing by a. It's like I'm dividing by a, right? A's will cancel. What's left over? Very good, right? Now in my right-hand group, which is the negative 2c minus bc, right? What is my greatest common factor there? Negative c, right? Very good. So now remember, it's like I'm dividing by negative c, like I'm dividing by negative c, right? So what's left over? 2. Very good, right? So in case you didn't see it, negative negative cancels out, c cancels out, negative negative cancels out, c cancels out, right? So that's how we get that at plus b. One more time, greatest common factor. I'm going to factor out that 2 plus b. And what's left over? A minus c. And that's it. Any questions on this? Anybody? No, it don't matter. 2 times 3 is the same as 3 times 2. Mhm. All right, let's take a look at another one. I'm s- hmm? No, it wouldn't matter. Like if you put the other on the other side, that's fine. Yeah. I know sometimes that happens. All right. So under the same title, excuse me one more time. Under the same title of factor completely, I have another question. Here we go. Try that out while I do some stuff. All right. Walk me through how to do this. AC method, right? Before we do the AC method, just want to recap real quick with everybody, right? So this expression is in the form ax squared plus bx plus c, right? So now let's try out the AC method, right? Well, before we do that, what is A? What is B? what is C? Not 3x squared. A is 3, right? It's the number, the coefficient in front, right? What is B? 1. And what is C? Not 2. Not 2. Negative 2, right? All right. So now what do I want to do? I want to do A times C, which in my case would be what? 3 times negative 2, which will give me negative 6, right? And then what do I want? I'm sorry. And then also for my B term, I have 1. So now this is a little tricky. I want two numbers that when I multiply them will give me a negative 6, but when I add them together will give me a 1. What are they? See it in? 3 and negative 2. Let's try it out. So 3 times negative 2 is in fact negative 6, but 3 plus negative 2, let's see what that is. That's positive 1, so that checks out. After we get those numbers, we want to rewrite our expression, right? So I have what again? I have 3x squared, but instead of the b term, I'm going to use the numbers that we just found. So this is going to be plus 3x minus 2x minus 2, just like that. And instantly I have 1, 2, 3, I have 4 terms, just like the previous question, right? So what do I want to do with these 4 terms, right? I want to factor them, right? By grouping, right? So I'm going to group these together. I have a left-hand group and I have a right-hand group. On my left-hand group, I have 3x squared plus 3x. What's the greatest common factor there? 3x, right? So when I factor out a 3x, like I'm dividing by 3x, like I'm dividing by 3x, right? What's left over? X plus 1. Very good, right? Remember, anything divided by itself is 1, right? A little bit harder now. I have negative 2x minus 2. What's the greatest common factor there? Negative 2, right? So remember, it's like I'm dividing by negative 2, like I'm dividing by negative 2, right? Negative 2's cancel out. What's left over? Plus 1, right? Negative is positive, and then the 2's cancel, making 1, right? So now, one more time. Greatest common factor. What's left over? I mean, what do they have in common? Perfect. What's left over? 3x minus 2. That's excellent. That's the whole thing. Any questions on this? Anybody? Does it make sense? All right. Let's take a look at another question. Got a little bit of a typo in this one, but that's okay. We can fix that. So you want to solve this quadratic equation by factoring, right? So what do we have? We have 5x squared plus 15x minus 50 is equal to 0. All right. Try that out real quick. I'm sorry? No, this one just do the AC method. Yeah. But use your trick from yesterday. Or the day before, whatever. What's up, man?
You said what's up?
I said, what's up?
Oh, I'm here.
Got you.
Did you want me to start it, or you want
Yeah,
me to?
start it over there. And I'll come check in a second.
Or you want me to
Yeah.
start?
Yeah.
Oh, I
Yeah,
thought you
start it.
want me to wait for you.
No, no, go ahead and start it up real quick.
All right.
Two. Mail. All right, back to this. Just finished the upload for yesterday, so I'm gonna get that email out to y'all in a second. All right, what should I do first here? Good. What is the GCF here? 5. Good. So I'm gonna factor out a 5 here. So remember, it's like I'm dividing by 5. It's like I'm dividing by 5. It's like I'm dividing by 5. So what's left over? Uh-huh. Uh-huh. Good. And that's going to be equal to 0, right? So now I want to factor this, right? Give it a little bit of space. So now I want two numbers that when I multiply them together will give me a -10, but when I add them together will give me a +3. What do we think they are? 5 and 2. Okay, okay. So 5 times 2, what is it? -2. All right, so 5 times -2 is -10, and 5 plus -2 is +3. Perfect, right? So this is going to be x plus 5 and x minus 2. All right. Last step that we have to do, right? We want to set both of these equal to 0, right? So I have x plus 5 is equal to 0, and I have x minus 2 is equal to 0. Very simply, just solve for x, all right? So I'm going to subtract 5 from over here. What I do to one side, I got to do to the other. I have x1 is equal to -5. I'm going to add 2 over here. But what I do to one side of the equation, I have to do to the other. So now what do I have? I have x2 is equal to +2. These are my answers. Questions on this? Go ahead. Uh-huh.
I can put the file and switch base to like the two numbers that and put them on my answer the same without the
No, no, that's good. Oh, like you didn't do the greatest common factor?
Yeah.
Okay.
Hopefully, minus three.
Okay.
Like about 5, want to see x plus 5, x minus 2.
Yeah. By right, it should be there. By right, it should be there. By right, it should be there. But you ended up with the right answer, so I don't know. It's gray area. Yeah. Yeah. Yeah.
Watch it then.
Yeah. Mhm.
You can watch it.
Oh, it's just a name. Because I have two answers. Like one is X1, the other one's X2.
Well,
That's all.
also in this case,
Yeah.
because of the zero, we don't know the group, we cannot do group.
Mm, we don't need to, because this is like the C method instead of the AC method, you know? But it's the same thing. Even if we did the grouping thing and all that, it would come out to the same answer. Yeah. It's just that the two numbers that you would find in the grouping, in this case being the 5 and the -2, right? You could just write them next to an X, and then that would be the factors. Yeah. Only when there's a number in front of the X squared, like the A, right? If that number is like bigger than one, then it's like we definitely got to do the grouping and all of that, you know? But you can like shorten it a little bit with the C method here if you don't have a number in front of the A.
With the grouping, the end of it as an answer.
Mhm.
With the grouping, you put
Yeah.
about.
Yeah. Yeah, it should be. Because look, if we were doing grouping, right? I'm gonna come over here. So it would be what? X squared plus 5x minus 2x minus 10, right? And when you group it, greatest common factor, x plus 5. And over here would be -2, x plus 5. And you factor that out, greatest common factor, this would be x plus 5, x minus 2. Oh, you're saying like if we didn't do the greatest common factor. Yeah, we'd still get the same answer. Yeah, it would work. I get what you're saying now. I'm sorry. Yeah. Yeah, if we didn't do the greatest common factor and we just went straight, so from here, the 5x squared plus 15 minus 50, right? If we just did the what's it called? The AC method from here, right? It would still give me the right answer.
We have to, like, 5 and 50.
Right. So that's like a massive number. Yeah. Yeah. Yeah.
The only number that
Yeah.
you 15.
Right.
5 and 10.
Yes. Yeah, it would still work out. Because in the end, you would have like a factor that you just solve for zero and it would come out to 5 and -2 again.
Yes, and comes out.
Yeah. Yeah.
The next 15.
Yeah.
So we're gonna like, x plus 5,
Okay.
5x -10.
That's fine. But when you solve for it, it's gonna come out to the same -5 and +2. Because like you add the 10 over, divide by 5, like that. Yeah.
Oh,
Yeah. So it's still the same. Yeah, yeah, yeah. But it's the same thing. What's up, man? Yeah. Uh-huh.
that odd outside of currency. Even -2.
It depends. Some people, yeah. Because like, huh? I don't know. Probably not. Yeah. But it's a gamble. Like if I tell you like to leave it out, by right it should be there. Like it's earned its respect to be there, so to speak. Yeah. All right, let's try something else real quick. So this next question, right, is called completing the square. Give you guys a minute to try this. All right, everything should have went out. Y'all should receive that email shortly. Anyway, all right, let's get back to this. So I have x squared minus 8x is equal to 1. And I want to solve this by completing the square, right? Who remembers what that magical formula was we did yesterday? Negative b over 2a exactly squared, right? And then after that, what do we want to do? We just want to plug in, right, our numbers, right? So in this case, what's my b? Very good. Negative 8 over 2 times 1. Remember, my a term must always be 1 whenever I'm completing the square. So if the a term is not 1, you divide every term, right, by a, right? Anyway, let's continue with this. Negative times negative 8 divided by 2 times 1 is what? Well, yeah, 16 in the end, right? I'll give you that. Exactly. All right. And then 4 squared is 16, right? Okay. So what does that mean? I want to take 16. I want to add that to both sides of the equation. So I'm going to add a 16 here. I'm going to add 16 here. Right? So now on the left-hand side, which is the x squared minus 8x plus 16, right? I want to factor that. So what do I have? What does that become? Good. Good, good. All right. Equals 17, right? So let's recap real quick, right? How did you know it was a minus? Right. So because the b term here is negative, I bring that down and make that negative, right? And how did I know that this would be a 4 right here, right? Very simply, because the number that I squared over here was 4. Just plug it in, pop, pop, and that's it, right? Probably help if I made this orange, right? There we go. All right, anyway, let's get back to this, right? So my goal in doing this, sorry about that. My goal in doing this, right, is to solve for x, right? So what should I do after this? Right, I'm going to square root both sides to get rid of the square. What I do to one side, I have to do to the other. These cancel out. So now I have x minus 4 is equal to plus or minus the square root of 17. And what do I do after that? Right, I'm going to add 4 to both sides. Exactly. Well, x equals 4 plus or minus square root of 17, right? So now, just to let you guys know, I will accept an answer like this. That's fine. You can also give me an answer like this: 4 minus square root 17 and 4 plus square root 17. I'll accept these two answers together, or you can give me this combo answer right here. Go ahead. What by define different?
Yes. Weird or not.
Did you complete the square?
Yeah.
Oh, so you're good then.
Well, a simple way, right? So that's whatever you want.
Mm-hmm. Mm-hmm. Right.
That's very minus x minus 40.
Are you saying that like you didn't get the same answer? All right. All right. So yeah, if you were on the test and you couldn't figure out the x minus 4 squared part, go ahead.
It's, it's because of those negatives for the is, that's why we got positive one.
Well, yeah, negative times a negative is positive, and then 8 divided by 2 is 4. Even if, even if you got that wrong, like, because there's another formula that exists, b over 2 squared, right? Even if you did b over 2 squared and got negative 4 squared, it's still coming out to 16, you know? So it's not that bad a thing. The reason why I use this formula, negative b over 2a, is because in math 30, this is considered to be your axis of symmetry, right? Again, I don't want you guys to have 5,000 formulas in your head. I rather you remember one formula that works for everything, right? Axis of symmetry is something that you need in math 30, right? So I rather just introduce it to you guys here and then just remember that going forward. It works, right? Clearly it works. The only caveat is that your A term must always be 1, right? And we're going to see another question coming up when the A term is not 1, but the A term must be 1. That's it.
I got the same.
As long as you got my same answer, I'm good. Now, I don't know how your professor is. Like, if you say you did it different, like, say you did the quadratic formula and got the same answer. Okay, okay.
Two. The b over two and then
Yeah.
b over two squared.
That should work as well. Yeah. But like I said, it's just too many formulas, you know? I'd rather you have one that works for everything that you remember. Go ahead. What were you saying, your friend? It is longer. Yeah, yeah. It's longer. To be honest with you, on the test, they're not even gonna outright be like, "Oh, give me the quadratic formula." Even though I know you guys learned it in class, like that's like an extra blessing that you have, extra tool, that you can use, so to speak. All right, this looks good. So we want to solve the quadratic equation and express the solutions in simplest radical form. You may use any method. So do whatever you want on this one, right? Just give me the answer.
They did it 3 times.
Nice.
Got 3 different.
No. We should get the same answer for all of them. Uh, all right, I didn't get no bounce back. So, Michael, since you on your phone, right? Did you get my email? I sent it. You got it? Cool, cool, cool. All right. Just wanted to verify that y'all received it. That's all. Because I didn't get no bounce back in my email, so it's like everything went through, So just wanted to make sure. All right. And then that's me? No. But that's a good email though. I should steal that. Cancels out the square, that's all it does. Just realized it's a brand new projector. It's very nice to me. Brand new. It's just a thought. It's just. Close. Make this line longer. As long as you get the final answer, I'm happy. You use whatever method you want. What? Right. That options. Other people, they got memorized. So, all right. Ouch. Let's take a look, because I know some of y'all are done already. Quadratic formula was real nice to y'all, right? I'm gonna complete the square, right? Just because no question on the test is gonna outright tell you to use the quadratic formula, you know? But they are gonna tell you outright like factor or outright complete the square, right? So let's see, I have 3x squared. Now, keep in mind, right? As long as you got the same answer as me, you good. You don't have to change nothing. Everything is right, all right? Because we could do whatever we want here. So 3x squared minus 9x plus 5 is equal to 2, right? So the first thing I want to do, right, is I want to put my constant terms on one side when I'm completing the square. So I'm going to subtract 5 from over here. But we've got to be fair. When I do the one side of the equation, I have to do the other side of the equation. So now what do I have? I have 3x squared minus 9x is equal to -3. Now, again, my a term has to be 1. So because I have a 3 in front of my x squared, I'm going to divide every single term by 3. All right? Again, if you did this by quadratic formula, you got the right answer, I'm happy. All right? No need to change anything. So now let's look at what I have. I have x squared minus 3x is equal to -1. Now we remember my formula, right? It's -b over 2a squared, right? And then I want to just plug in my numbers, right? So this is going to be negative of -3 divided by 2 times 1 squared. When you do the math on that, what does that become? That becomes 3 over 2 squared, which becomes what? 9 over 4. Did I lose anybody or are we good? Good. So now that 9 over 4 is what I want to add to both sides of my equation. 9 over 4, 9 over 4. All right? How did I what? 3 over 2 squared. Yeah, so you just square the top and square the bottom. Yeah. All right. So now, on my left-hand side, I have x squared minus 3x plus 9 over 4. I want to factor that. Tell me what I'm going to write in there. I'll give you a hint. The first letter is x. What goes next to it? Say it again. Minus. Okay, good, good. Minus what number? No. 3 over 2. Right? So whatever number it is that I square, that's the number that's going to go inside the parenthesis. And whatever the b term is, the sign of the b term is going to be the sign that goes inside. That's simple. All right? And then equals, I got to do a little math on this. -1 over 1 multiplied by 4. It probably is 5 over 4. Let me see. Yeah, it is. So 5 over 4. Yeah, just remember whenever you're dealing with fractions, you got to have the same denominator in order to add or subtract them. That's all. All right? Okay. Now that I got this far, right, I want to solve for x. So I want to get rid of that square term. So what am I going to do? I get rid of a square. Radical, right? So I'm going to do the square root over here. But what I do to one side, I got to do to the other, right? This cancels out. So what do I have now? I have x minus 3 over 2 is equal to plus or minus square root 5 over square root 4. Somebody help me. What's square root 4 again? I forgot. 2, right? So this becomes x minus 3 over 2 is equal to plus or minus square root 5 over 2. And what's my next step after this? I cancel out the 2. Get x by itself. How do I do that? Exactly, right? So I'm going to add 3 over 2 over here. And what I do to one side, I got to do to the other. So now here goes my final answer. X equals 3 over 2 plus or minus square root 5 over 2. I will accept this answer. If you want to give me the same answer under a single radical, I accept that too. So if you want to give me 3 plus or minus square root 5 over 2, I will take this answer as well. All right? If you want to separate the two answers, I respect that as well. I'll take that as well. So if you want to give me 3 minus square root 5 over 2, along with 3 plus square root 5 over 2, I will take that. That's fine too. I'll take that. As long as you got one of these answers here with the quadratic, I'm happy. You didn't get it with the quadratic? Complete the square then, man. Yeah. Because here's the problem with the quadratic, right? I don't know your professor, but some professors will give it to you, some professors won't, right? And if you have a professor that doesn't give it to you, then it's hard, right? But on the test, right? They're gonna outright ask you for two processes, right? Completing the square and factoring, right? You could do whichever one you want. To me, I'd rather you guys walk in with just those two topics than to come in with a third topic. You know, you find it easier? Yeah. Well, you did it well, so keep it, But the problem is remembering it, you know? So let me see. X equals negative b plus or minus the square root of b squared minus 4ac all divided by 2a. It's a lot to remember, you know? So if you memorized it, cool. And you want to use it, cool. Right? If not, just go in there with completing the square and with factoring, you should be good for the whole test. All right. All right, let's keep it moving. A little bit different, this question. So I want to simplify this, right? This is what do we call this again? Multiplying rational expressions, right? Now, in order to multiply them, right, I got to factor them first, right? Cross out the like terms. Like terms can be top and bottom, or they can be diagonal. And then whatever's left over is my answer. All right. So let's try this out. What's the numerator going to be? I have x squared minus 1. Factor that for me. Very good. Right? That's a difference of two perfect squares. So I'm going to have x plus 1, x minus 1. What about the denominator? A little bit harder. What's that going to be? An x plus 1. Very good. Right? So I wanted two numbers that multiply to give me a positive 2. And when I add them together, it will give me a positive 3. So that's just 2 and 1. Not that bad, right? I'm going to use a dot multiplication in this case because I have what's it called? X's in this expression, excuse me. And then I'm going to have what on top? X plus 2 divided by x. Now, all you have to do is just cross out the like terms, right? And we could cross out up and down, or we can do diagonally, all right? So tell me, what are some like terms here that you see? Okay, so x plus 2 and x plus 2, and x plus 1 and x plus 1. Very good, right? So whatever's left over, that's your final answer. So what do I have? I just have simply x minus 1 over x. And this is my final answer.
Let's say like. You got parentheses x minus 1 over x.
Nah, I just do that out of preference. All right. Was any questions on this? Is everybody clear on this process? We're good? Okay. Remember, I want everybody to get 100 on the final. All right. I want y'all to brag about it. All right. Yeah, man. When y'all get 100, make sure y'all post it to the BCC Instagram page, right? Right, we wanna blow that up. 100 and Matt 28. There is a Facebook page, but I don't know if it's that active anymore. Yeah. Yeah, man. Yeah. I mean, if y'all really want to go to the next level, call Bronx News 12. Be like, yo, listen, like, All right. This question. Let me give y'all a second to try this. Yeah, try it out real quick. Try it out. Just wanna check some things. All right, let's try it out. So now let's notice something, right? I have a rational expression, right? Divided by rational expression. So what should I do first? Keep, change, flip, right? So I'm going to keep the first term. I have 7x over the x squared minus 5x minus 14. I want to change that division to multiplication, right? In this case, I'm going to use a dot multiplication because I have x's in this question, okay? And then I want to flip the other term, right? So this is going to become what? X plus 2 over x squared plus 5x. All right? Now, let's do everything else, right? Let's factor, cross out like terms, all that good stuff, right? So factor this for me, please. What do I have? So x minus 7 and x plus 2. Very good, right? Two numbers that multiply to give you negative 14, and when you add them together, will give you negative 5 times. Very good. Greatest common factor in that denominator. All right, so let's cross it out. What we got?
X. Plus two, so.
And the x's, right? Very good. So now let's look at our final answer. Final answer is going to be 7 over x minus 7 times x plus 5. And that's it. Any questions on this? Good? All right, let's keep it moving. Can't wait to get to this trig, you know? That's my favorite part. All right, this next question is not so bad. So same idea, right? We still got the rational expression thing going on, but we want to subtract the two of them. So, all right, so try that out real quick. Finished? Let's see. So, first term, what's the denominator going to be?
X plus 5.
Good. Perfect. And then minus the 7 over x plus 5. Now remember, I want both the denominators to be the same. So how can I do that? Right? Multiply by what? Right. X minus 5, right? But we got to be fair, right? What I do to the bottom, I got to do to the top. Right? And then after that, just simplify the top, and that's the end of the whole question. Let's take a look. So I have 5x minus 7 times x minus 5 all over the x plus 5, x minus 5. All I'm going to do here, just distribute that 7. And that's it. All right. So I have 5x minus 7x. A negative is positive, 35. All over the x plus 5, x minus 5. Let's combine like terms. Let's see what happens. I have negative 2x plus 35 all over the x plus 5, x minus 5. And that's it. That's the whole question. Questions on this, anybody? Everybody got the same answer? All right. Let's look at something else. I really want to get to that trig. All right, so this question now. Technically speaking, we kind of did a question like this already, right? This is a rational expression divided by a rational expression, right? So first thing we could do is we can rewrite this. Well, actually, no, before I rewrite this, the first thing I should do, right, is I should make it a rational expression divided by rational expression, not a rational expression divided by a difference of rational expressions. All right. So I'm going to do this a little bit different, the way that you were going to do it yesterday. All right. So what I want to do is I want to get the same denominator under the bottom one. All right. So I have 7 over x plus 3 minus 4 over x minus 3, right? How can I make those denominators the same? What can I do? LCD, right? And what would the LCD be for the bottom?
-3, and then 4 would be the x plus 3.
Good. So LCD would be x minus 3, x plus 3. So I'm going to multiply each one of these. Right? I'm going to multiply the 7 one by x minus 3, but what I do to the bottom, I do to the top. I'm going to multiply the 4, the one with the 4, the x minus 3 by x plus 3. What I do to the bottom, I do to the top. So let's take a look at what we have now. So I should have 3 over x squared minus 9 over 7 times x minus 3 minus 4 times x plus 3 all over x plus 3, x minus 3, right? After that, let's simplify the top. Distribute, combine like terms, all that good stuff, right? So next line should be still 3 over x squared minus 9. And then now I should have what? 7x minus 21 minus 4x minus 12 all over the x plus 3, x minus 3. Did I lose anybody, or are we all on the same page? We're good? All right, so now I want to combine like terms. That's a fancy way of saying that I'm going to add, all right? So this is 3 over x squared minus 9 over 7x minus 4x. What's that? 3x. Negative 21 minus 12. What's that? Like negative 33. All divided by the x plus 3, x minus 3. This is what I wanted to get to, right? I have a rational expression divided by a rational expression, right? So I can rewrite this now as 3 over x squared minus 9 divided by the 3x minus 33 over the x plus 3, x minus 3, right? Now remember, when we're dividing these expressions, right, we want to keep change flip, right? So this is going to become 3 over, x squared minus 9. Change that division to multiplication. I'm going to use a dot multiplication because I have x's in this expression. And I'm going to flip the second term. So it's going to become x plus 3, x minus 3, all over the 3x minus 33. Right? Now, what's next? Exactly. I'm going to factor them, right? So what do I have when I factor them? I have 3 over what? Very good. Times, I have the x plus 3 up top, x minus 3. What's the denominator going to be?
Oh, X. Minus 11.
It's close. 3 times x minus 11, right? Greatest common factor. And then I want to cross out the like terms, right? So I have x plus 3, x plus 3, x minus 3, x minus 3, 3 and 3, right? So my final answer here is 1 over x minus 11. Any questions on this one? Yesterday, what we did was we found an LCD and multiplied it by the top and the bottom so that all we had to do was just reduce the fraction. All right. Whichever method works for you, use. All right. You have the video of the one from yesterday, and you're gonna have this video later today. So you can, whichever one works for you, you just use that. All right, let's keep moving. I'll take it up a notch real quick because I see time is like kind of running against us. So I want to solve for x here. All right. I have x over x minus 2 plus 3 over x plus 7 is equal to 2x plus 29 over x squared plus 5x minus 14. All right. What should I do first? Somebody tell me. Before I do that, though, factor, right? So factor the bottom for me. What am I going to have? Mhm. Very good. All right. So now, now, what's my LCD? X plus 7, x minus 2. Very good. Very good, very good. So I want every term to have the same denominator, right? So I'm looking at the first term, which is x over x minus 2. What do I have to do to that to make it have the same denominator as the LCD? Perfect, right? So I'm going to multiply this by x plus 7, but what I do to the bottom, I got to do to the top. What about the x plus 7? The 3 over x plus 7, excuse me, right? I want that to have the same denominator as the other two terms. So what do I have to do to that? Right? I'm going to multiply by x minus 2. But remember, what I do to the bottom, I got to do to the top. Now, this is key. This is an equation, right? This is an equation. It has an equal sign, right? So that being said, I no longer need my denominator, right? Only when you have an equation with an equal sign can you get rid of the denominator. So in this case, my answer is x times x plus 7 plus 3 times x minus 2 is equal to 2x plus 29. And then the rest of this is simple. Just distribute, combine like terms, solve for x, all that good stuff. All right. So this would be x times this. This is going to be x squared plus 7x. And then 3 times this is going to be plus 3x minus 6 is equal to 2x plus 29. Combine like terms. X squared plus 10x minus 6 is equal to 2x plus 29. Now, my goal is I want to get all my x's on one side. I want to solve for x. So I'm going to subtract 2x from over here. I'll do to one side, I got to do to the other. And then I want to subtract 29 from over here. I'll do to one side, do to the other. So now I have x squared plus 8x minus 35. Ooh, yeah, minus 35 is equal to 0. We have a quadratic. You could do whatever you want with this, right? I'm really, really in love with completing the square, so I want to do that again, right? So I'm going to add 35 over here. What I do to one side, I got to do to the other. So now I have x squared plus 8x is equal to 35. You remember my formula, right? This is negative b over 2a squared, right? My a term is 1, so I'm good to go. Just plug it in, right? This is going to be negative of 8 divided by 2 times 1 squared. That gives me what? Negative 4 squared, which is 16. You're going to add 16 to both sides of this equation. So add 16. Oh, let me do it on the bottom. I'm going to add 16 over here. I'm going to add 16 over here, right? On the left-hand side, I have x squared plus 8x plus 16 is equal to, oh Lord, I'm never going to hold you. What is that, 11? This is here, that's 4, that's 51, right? How you doing, man? So help me out. What's this going to become? X plus 4. Very good. All right. My B term is positive. Boom. And the number that I squared over here was 4. All right. That's simple. And after that, just solve for X. Keep it simple, right? Just solve for X. And yes, you could have used the quadratic formula on this as well if you wanted to, right? So I'm going to square root both sides. So now I have X plus 4 is equal to plus or minus square root 51. Subtract 4. We do to one side, we do to the other. So I have X is equal to negative 4 plus or minus square root 51. All right. I will take that answer. If what you call it? If you don't want to give me an answer like that, you want to split them apart, that's okay as well. So I will accept negative 4 minus square root 51 and negative 4 plus square root 51. That is acceptable together as well as an answer if you want. All right. Questions on this? Now, generally speaking, right, you have to verify that the answers that you got, right, in this case it would be the -4 minus square root 51 and the -4 plus square root 51. You have to verify that those answers will not make your denominator 0, right? Because if it makes the denominator 0, it's undefined. So technically what you're supposed to do is you're supposed to plug them into your LCD to verify that they will not become 0, right? One by one. Also plug them in one by one, right? In the interest of time, I'm not going to plug them in because you could clearly see that that's not going to make the denominator 0. The only two numbers that would make the denominator 0 is -7 and +2, right? I just take each one of the factors and set them equal to 0, and that's how I get the denominator to be 0. So what does that mean, right? Any answer that you plug in for this is right, except -7 and +2. That's what it means in a nutshell. All right. Questions on that? Good. All right, let's keep it moving. We go back to the bottom in case you guys didn't get the answer. We're going to simplify some expressions real quick using radicals. All right. On your test, I don't believe the radicals will be this large, right? But the idea is still the same, right? What's the largest perfect square that goes into 20? I think 5 and 4, right? So this is going to be square root 4 times square root 5 plus 3 times, right? Largest perfect square that goes into 45. 9 and 5, right? Square root 9, square root 5. Bring down that minus sign, right? Largest perfect square that goes into 500. Not 500. Yes. That's it. Square root 100 and square root 5. And then after that, you just simplify the perfect square. So square root of 4 we know is 2. Square root 5 plus 3 times square root of 9 is 3. Square root 5 minus square root of 100 is 10. Square root 5. Let's do a little multiplication. This becomes 2 square root 5 plus 9 square root 5 minus 10 square root 5. Right? 2 plus 9, this is going to be 11 square root 5 minus 10 square root 5, which will leave me back as just 1 square root 5 as my answer. Questions on this? Anybody? This made sense? All right, let's keep moving. So our instructions are again to simplify the expression that's still on the table. Here's my next expression. So I have square root of 6 minus 2 squared, right? That is the same thing as writing square root of 6 minus 2 times square root of 6 minus 2, right? And all you have to do is just distribute, combine like terms, all that good stuff, right? So what's my answer going to be? Okay, I'll take it. Square root 36. What else? Very good. What else? Last. Not 6. Right? Positive 4, right? And then now we want to simplify that radical. So now I should have 6 minus 2 square root 6 minus 2 square root 6 plus 4. And then we want to combine like terms, right? Numbers with numbers, radicals with radicals, right? So tell me what the answer is. Mm-hmm.
Four.
Minus 4 square root 6. Perfect. And that's it. Just add them together. Any questions on this? Anybody? 36. So that's square root 6 times square root 6. Yeah. Oh, like how you get square root 36? It's 6 times 6 is 36. Oh, my fault. So that's negative 2 times square root 6. Wait, I'm sorry. Hold on. Let me say it again. That's square root 6 times negative 2. And then that's negative 2 times square root 6. That's where the two of them came from. Yeah, exactly. I'm just foiling. Yeah. Yeah.
Once you go past the final, those numbers, so how do we get to 10 minus 4 is for reasons?
So I add the two numbers together. So that's a 6 plus 4. That's going to give me the 10, right? And then I add these two together, the negative 2 square root 6 and the negative 2 square root 6. Yeah. You're welcome. So we can look at the next one. Everybody? Go ahead.
You plus 6 was square root of 36 is 6, right?
Correct. Yeah, correct. Yeah. This next question, please, nobody get it wrong. It's probably the easiest question on the whole test. I mean, even though we all going for 100, right? This is probably the easiest question on the whole test. So I got 27 negative 2 over 3. I want to write this answer out, basically simplify it. Simplify the expression. So first things first, right? Anytime I raise a base to a negative power, it drops down into the denominator and becomes positive. For example, let's say I have x raised to the negative 2 power, right? That's going to become what? 1 over x squared, just like that, right? Same thing's going to happen here. This is going to become 1 over 27 to the 2/3 power. So notice it went down into the denominator and it became positive, right? After that, now we're just going to solve it. Now, when you have a fraction power, whatever is in the denominator of the fraction, right, that's going to be your root, right? So look, this is going to become what? 1 over the cube root of 27. And then when you get that answer, you square it, right? Now, what is the cube root of 27? 3, right? Very good. So this becomes 1 over 3 squared. And what's 3 squared? 9, right? So final answer, 1 over 9. And that's it. All right. Any questions on this? Anybody? Yes. Yeah. Now for me, I didn't really know that 27 was 3, right? So sometimes when you don't know what to do, you can always use prime factorization. So say I have 27, right? Break it down into two numbers that multiply to 27. That's 9 times 3. 3 is a prime number, so I'm good with that. Then I could break down a 9 into 3 times 3. These are prime numbers. So I see that there's 1, 2, 3. So 3 times 3 times 3 gives me 27, right? So if I do the cube root of 3 to the third power, right? The cube root and the 3 and the third power will cancel out, leaving back just 3. That's another way to get this 3 right here. All right. Just in case you have like a really, really large number, you're not going to have a large number for your test. But just in case you have a really, really large number, this is a way to do it, you know? All right, this next one right here is probably the most difficult question on your test. I'm gonna be honest with you on that. This is probably the hardest question on the whole test. All right? So we want to simplify this expression. It's a little complicated, right? What I like to do is I like to break this up individually, numbers and variables individually, and then I simplify by the power on the outside. So let's check this out, right? So I want to break this up into 8 over 27, let's say times x to the 6 over x to the third times y to the 7 over y, and all of that is raised to the 2 over 3 power. Individually, right, let's reduce the inside first, and then we'll worry about the power on the outside, right? So this is going to become the same 8 over 27, can't do nothing with that, times x to the 6 divided by x to the third becomes x to the third power, right? So anytime we divide exponents, we subtract their powers. So 6 minus 3 is 3. What about the y to the 7 divided by y? What's that going to become? Y to the 6. Very good, right? Same thing, right? We subtract their power. So 7 minus 1 is 6. This is going to be 2 over 3 power. Now that I have all that out of the way, I can deal with the 2 over 3 power, right? So individually, everybody, 8 over 27, you're going to get a 2 over 3 power. X cubed, you're going to get a 2 over 3 power. And y to the 6, you're going to get a 2 over 3 power. Just like that. And then we're just going to solve them individually. Nice and simple. You remember for the numbers what's going to happen, right? This is going to become cube root of 8 squared divided by cube root of 27 squared times, whenever I raise a power to a power, what operation do I do? Whenever I raise a power to a power, what operation do I do? Not square root, starts with an M. When I raise a power to a power, not add them, multiply them, right? So this is going to become x to the 3 over 1 times 2 over 3 power. And it's going to become y to the 6 over 1 times 2 over 3 power. And then we just simplify these, right? We're just going to answer them. Cube root of 8 is what? 2, right? This becomes 2 squared over cube root of 27, we said was what again? 3, right? 3 squared times, this is going to become x to the, right? 3 goes into 3 ones, 3 goes into 3 ones. This is just x to the second power, x squared, times, we're going to do the y. 3 goes into 3 ones, 3 goes into 6 2 times, 2 times 2, this is 4, right? Finally, let's finish out our numbers. This is going to be 4 over 9 times x squared times y to the fourth. I will take this answer if you want to give it to me that way. Or if you want to put it together, I'll accept that too. So if you want to tell me that the answer is 4x squared y to the fourth over 9, I'll take this answer as well. Whichever answer you like better. All right. Questions on this? Any questions on it? Good. All right, let's keep moving. I know we all want to get to trigonometry. We're almost there. This question is not so bad. So I want to rationalize the denominator here. Remember, it's illegal for me to have radicals in my denominator, right? So in this case, I have 3 over square root 5 minus 1. How can I get rid of this denominator, this radical in my denominator? Right, multiply by the conjugate, right? What is the conjugate here? Plus 1, right? So it's the same thing, but instead of the minus, you're going to have a plus. If this was a plus, I would have put a minus here, right? Right, conjugate means opposite, so opposite sign, right? After this is straightforward, just distribute, combine like terms, all that good stuff, right? So for the numerator, you already know this is 3 times square root 5 plus 3 times 1, so this is going to be 3 square root 5 plus 3, very simple. On the denominator, however, right? Square root 5 times square root 5, we know square root 25. Square root 5 times positive 1 is 5. And then negative 1 times square root 5 is negative square root 5. And then negative 1 times positive 1. Negative 1, right? Let's simplify that square root. This becomes 3 square root 5 plus 3 over 5 plus square root 5 minus square root 5 minus 1. You know that square root 5 minus square root 5 is just going to cancel, right? So I don't need to write that again. All right. So really what I have is I have 3 square root 5 plus 3 over 5 minus 1. What's 5 minus 1 again? 4, right? So this becomes 3 square root 5 plus 3 over 4. And that's my answer. All right. Any questions on this? Rationalizing the denominator. That's what this is called. Any questions on it? Okay. So we good? Let's take a look at another question. It's a few more questions to go until trig. Gotcha. Some of these questions are a little, what you call like quick, like this one is quick. So I want to, again, rationalize the denominator. It's illegal for me to have radicals in my denominator. In this question, I have square root x minus 3 square root y over the square root of x, right? How do I get rid of the radical in my denominator here? All right, so I'm going to multiply by square root x. What I do to the bottom, I do to the top. And then the rest of it is straightforward, just distribute, all that good stuff, right? So square root x times square root x is, it is. I'm just going to write x, though, for time. Yeah, it's just x. And then square root of x times negative 3 square root y is xy, perfect. And then square root x times square root x is just x, right? This is my final answer. Questions on this, anybody? This one's kind of quick. Pop, pop, and that's it. All right? We good? All right. We almost there, almost there. Want to see them triangles. That's what I want to see. See them triangles. All right. So we have this equation here, right? It's an equation because I have an equal sign. So I'm looking for an answer. That means that my answer is going to be x equals something. I don't know what it is, but x equals something, right? So first thing we want to do, right, with these radicals, right? I want to isolate the radical and then solve for x, right? So first thing I want to do is what? Get rid of the 2, right? I'm going to subtract 2 from over here. What I do to one side, I got to do to the other. So now I have what? Square root x squared minus 16 is equal to x minus 2. What should I do after that? I want to get rid of the square root, right? How do I get rid of the square root? Right?
Both sides to the second.
Exactly, right? I'm going to square it to get rid of the square root. But what I do to one side, I do to the other, right? The square root and the square root cancel out, leaving back x squared minus 16 is equal to x minus 2 squared. On the right-hand side, you want to expand that, right? You want to expand that. So this is going to be x squared minus 16 is equal to x squared minus 4x plus 4. I know you guys know how to distribute already and all that in FOIL, so I'm just giving it out to you. After this now, I want to solve for x, right? Solve for x. That's my goal, right? So what am I going to do? I'm going to subtract x squared from over here. What I do to one side, I got to do to the other. And then I want to subtract 4 from over here. What I do to one side, do to the other. Now, what do I have? I have negative 20 is equal to negative 4x. And then after that, you just want to solve for x. So I'm going to divide by negative 4. What I do to one side, I got to do to the other. So now I got x is equal to positive 5. And that's my answer. What's up, man? Questions on this? Come here 1 second. Sign this up real quick. First name, last name, impolite email. No, this is for the computer. It's not a real pen. Yeah. When you get a chance, man, pass it to this gentleman over here. When you finish, pass the paper over there so you can sign it. Yeah. Uh-huh.
X squared minus 16 equals x minus 2 squared. How do we get to the x squared minus negative 4x plus 4?
Got you. So this is actually x minus 2 times x minus 2. And then you can just FOIL it. X times x, x squared. X times this is negative 2x. Negative 2 times x is negative 2x. And then negative 2 times negative 2 is positive 4. And then you just combine like terms, right? So then you get x squared minus 4x plus 4. So that's how you get that. Okay. Any other questions on this one? All right, just want to get the answer, right? After we get the answer, we're good to go. Let's take a look at another one. Not gonna lie, this next question right here, this is really hard too. This one involves complex numbers. Whoops, I hit the wrong button. Okay. Here we go. So I got 3 minus 5i times 2 minus 7i minus 4 minus 3i. All right. To me, this is really, really complicated, this question, right? What we have to do is we have to distribute twice, and then we want to combine like terms, right? So let's take a look at that. It's gonna be a little challenging. Appreciate you, man. Thank you. All right. All right. So 3 times 2, 6. Then I got 3 times negative 7i. So negative 21i. Very good. All right. So then minus 10i. And then plus 35i squared. All right. And distribute the negative minus 4. And then good. Last one. Plus 3i. Did I lose anybody? Everybody's good with this? We're just distributing twice, right? After that, we want to take care of that I squared. I squared becomes what again? Negative 1, right? So this is going to become 6 minus 21i minus 10i plus 35 times negative 1 minus 4 plus 3i. Right? Let's do a little multiplication now. Right? This should be 6 minus 21i minus 10i minus 35 minus 4 plus 3i. All right? And then now, here's the hard part. I want to combine like terms, which means I want to add, right? So add this up. Tell me what you get.
Negative 33 minus 28.
Minus 28. I think so. Yeah. Yeah. 31, 38. Yep. Any questions on this? Anybody? Any questions? This one's a little complicated, so I understand. Go ahead.
I was just wondering where the height for 35 is because it's I squared.
Yeah, I squared becomes negative 1.
Oh.
Yeah, and then negative 1 times 35, negative 35.
Minus 1i minus 10i minus 35 minus 4 minus plus 3i.
Yeah. Oh, the 28. So negative 21i minus 10i, that's negative 31i plus 3i, negative 28i. Got you. Good questions, though. Good questions. Anybody else? So we can. You could.
Yeah, then you could like see it like
Separate? Okay. I don't know. As long as you get the right answer, I'm happy. As long as we're on the same page at the end of the day. See what else we got here. Oh, hallelujah, finally. Finally. We got to the promised land. So we good? I can move on? Triangles. Yay. It's the best part of the exam right here. So I have a right triangle, ABC. It's a right triangle, and I want to find what is tan of A and cosine of B. I'm gonna write that over here, tan of A and cosine of B. Okay. So here's this triangle right here, ABC, right? I have another side over here, the hypotenuse. I want to figure out what C is. How can I do that? Very good, right? So I could use A squared plus B squared equals C squared, right? And in this situation, what do I have? 4 squared plus 5 squared is equal to C squared. And let's do the math on that, right? 16 plus 25 equals C squared. And that's like what? 34, like 41 squared? No, 41 equals C squared, right? Exactly. And we want to square root both sides. So I got a C equals square root 41. Not too bad, right? So C is square root 41. Just verify. Good. Okay. Back to the question at hand, right? They want to know what is tan of A and what's cosine of B. So there's a little acronym that we can use to help us with that. It's called SOH CA TOA, right? And what it stands for is sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tan is opposite over adjacent, right? Let me define what these are, right? Opposite is something that's straight in front of you, like it's straight up, it's like away from you, right? So if I was at angle A, for example, the opposite would be here, leg A, right? It's away from you, right? Adjacent means next to you, right? So adjacent is next to you. So again, if I'm at angle A, adjacent would be B, right? Adjacent would be B. C, the longest side right here, this is your hypotenuse, right? There's no, so when they say H hypotenuse, it means C. Okay, anyway, let's get back to the question. They want to know for tan of A, right? Let me do some blue. Tan of A, what is the answer? Tan, we know is opposite over adjacent, so what would you say it is? 4 over 5, good. 100, right there. What about cosine of B? A little bit harder. Cosine of B. No. 4 over radical 41. That's it. So look, I'm here B, right? Opposite B is leg B, right? But adjacent to B is leg A, right? Adjacent means next to, right? So 4 over radical 41. I have a problem though. I'm not allowed to have radicals in my denominator. So we have to rationalize its denominator. So you're going to multiply this by radical 41 over radical 41. Final answer, 4 radical 41 over 41. The 4. So if I'm at angle B, right, because they want cosine of B right here. Adjacent is next to, right? So this is adjacent, ADJ, right? Opposite to angle B is leg B. This is opposite, right? If that helps. Questions on this?
I was just wondering if we're gonna get a formula sheet for stuff like tan and cosine, or is that we have to memorize it?
Depends on your professor. Yeah. Who do you have?
I have, see,
Maybe you might. I don't know. Maybe. But if you have to memorize it, just memorize it. So katoa. right? Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tan is opposite over adjacent. Yeah.
Like three more functions and just the inverse of these.
Right.
You can't have them on the afternoon.
No, they work. They work. So look, let me show you what that would be, right? So I still have the SOHCAHTOA, right? Let me go back to my green real quick. You know, we got to do the BCC green. You know what? No. Hold up. Forgot that tomorrow's Wednesday, right? Knicks is playing, so we're going orange right now. All right. So we still got our SOHCAHTOA. All right. All right. So remember, SOHCAHTOA is like sine. And the C in this is cosine. And the T in this is tan. Right? The other three that they have, right, is you have something called cosecant. Right? And cosecant is 1 over sine. Then you have something called secant. Secant is 1 over cosine. And then you have something called cotangent, which is 1 over tan. All right? So long story short, right? Let's say that, which one do I have here? Let's say cosine B, right? So remember I had cosine of B, which turned out to be, what was that? 4 over square root 41, right? If I how can I say this now? If there was a secant question, right? So say they wanted secant of B. All I would do is take the cosine of B and plug it into the formula. So this would be 1 over, instead of cosine B, it would be 1 over 4 over the square root of 41. Long story short, when you do the math, keep change flip. This is just going to be square root 41 over 4. So when you have those other three, you flip the answer that you got for the first one. So for cosine of B, I got 4 over square root 41. Secant of B is the reverse, square root 41 over 4. That's the other ones right there. I don't know if they're gonna give you cosecant, secant, and cotangent on the test. I don't think so. But this is it. If you want to see, you know. Yeah. Another thing to remember, right? Always remember in life that there is one co and no coco. All right? One co, no coco. So that being said, right? Each one of these has a co, right? Cosecant goes with sine, cosine, right? And then you have cotangent goes with tan, right? Each one of those pairs has a co. You can only have one co, no coco, right? So cosecant is not 1 over cosine, it's 1 over sine, right? And secant is 1 over cosine, all right? So that's a little thing that I came up with to help you remember that, right? And then tan is easy, you know, cotan is just 1 over tan. Everybody know that. That's nothing. All right. Questions on this? We good? All right, let's knock out the fun question. Nah, that's the easiest question on the whole test. Now, what makes this question a little bit harder, I'll give you that. What makes this question a little bit harder is that they're not going to give you a triangle for this, right? So it's just a blank question. When you're on your test, right, the question above this is going to have a triangle. Do not use that triangle for this question. Completely different question, right? Completely different, all right? All right. So this says triangle ABC is a right triangle with C equal to 90 degrees. If tan of A is equal to 3 over 5 and A equals 12, find C, right? So here's how you do this question, right? I want to make two triangles, right? I'm going to call this one 1. So I'm going to say that this is A1, B1, C1. This is a right triangle, right? And this would be what? Leg A1, leg B1, and this is like leg C1, right? And then I'm going to make a second triangle. I just realized that this would have been the perfect opportunity to do blue and orange, but damn. I'm gonna get it in. I'm gonna still get it in right here. We're gonna do an orange triangle. All right. Same thing. Let's call this A1, C1, B1. This is, excuse me. Whoops. I meant to call this triangle 2. So A2, C2, A2, C2. This is B2. And this would be C2. Okay. In the question, what they're asking you for is they want C2. That's what they're looking for. All right. So let's look at what we first have, right? So we have that tan of A is equal to 3/5, right? Tan of A is equal to 3/5. So right here is angle A. That's angle A right there. So it says 3/5. Tan is what? Who remembers what tan is? Opposite over adjacent, right? SOHCAHTOA. Ran out of space, right? So the opposite from angle A is what? What number am I going to write for leg A? 3. And what number am I going to write for leg B? Very good. Opposite over adjacent, right? I don't have that leg C1. I don't have that. How can I find that? Pythagorean theorem. Very good, right? So I have A squared plus B squared equals C squared, right? In this case, 3 squared plus 5 squared equals C squared. Let's keep it moving. 9 plus 25 equals C squared. What is this, 34? Equals C squared, something like that. Then you want to square root both sides. So we get C is equal to square root 34. Right? That being said, C1 is square root 34. All right. I got all that information from the first part. Tan A is equal to 3/5, right? Now, let's look at the second part right here. They're telling me that A is equal to 12. You see that? A is equal to 12. So what that's telling me, right, is that in this triangle right here, my A is 12, right? I want to figure out what is B and what is C, right? What is B and what is C? Well, no, I'm lying. Hold on. Woo. Going too fast, going too fast. I want to figure out what is C. That's my goal. That's my end game. What is C? All right. So more specifically, the C I'm looking for is this C. The answer for here. So easiest way you could do this, use similar triangles, right? These are the same. So I know what A2 is 12, right? And I want C2. So watch what I'm going to do. I'm going to do C1. Hold on. Let me match the colors so it makes a little bit more sense, right? I want to do C1 over A1 is equal to C2 over A2, right? And all you're going to do is just plug in the numbers from each triangle, cross multiply, and that's your answer. All right. Let's take a look. Let's try it out. 3/5. We're going to have, I'm trying to think. Hold on. So I have square root 34 over A1, which is 3, is equal to, what did I have over here? C2, that's what I'm looking for, over A2, which is 12. All right. After we have that, light work, right? Cross multiply these two, and these two, and these two, right? So 12 times square root 34 is equal to 3 times C2. So 12 square root 34 is equal to 3 C2. Divide by 3, right? 12 divided by 3 is what again? It's like 4, right? So this is 4 square root 34 is equal to C2. That's my final answer right there. Like work, right? So this is 4 square root 34. That's my answer. All right, ask some questions. I know that was a lot. I could. It's the same process as this. But wait, on this one though, is there any other questions on this one before I jump into another example? Oh, like you want to see this work right here? I got you. I got you. No, no. There's a session at 2 o'clock? Really? I had no idea. That's not me though. I actually have to go over to the lab for tutoring. Yeah. But I am recording this. This is why I asked for your emails. I'm gonna email you guys this after I downloaded and uploaded and all that good stuff. Mm. And you guys have the email from yesterday, so you're good to go. Mhm. Everything you missed, I got you. All right. So you asked for another question like this. I got you. Second. That wasn't me. I don't know why I did that. So what I want to show you guys, something that you guys can do. Everybody here, right? You all have an email address, right, from the school. We using that email address, right? You can use Microsoft Copilot. So something I'd like to show you guys that you can do. I'm gonna, you're welcome. See you in a little bit. And good luck today. Okay. So I want to share something with you guys. 1 second. This. So this right here, this is Microsoft Copilot. All of you have access to it. All right. What I'm gonna do, I'm gonna steal a question. Now, I have trouble taking questions from the PowerPoint that you all have access to. That was the QR code that you guys scanned earlier. Oh, you guys didn't get the QR code? I got you. Hold on. Real quick, let me show you this and I'll get you guys a QR code at the end real quick. All right. So I have a similar question that I just copied and pasted from the practice review, right? You guys probably all have the practice review for the final, right? What you want to do in Copilot is you could say, give me a question like this, right? And then maybe you want to put like some quotation marks or something just to show it what you're looking for. And boom, right? So I typed in cosine A is equal to 1/3, right? Where the other similar triangle is going to be B is equal to 2. And it spat out sine B is equal to 4/5, where the other similar triangle will be A is equal to 3. From that, right, you can use it to get other questions. So what am I suggesting you do with this, right? You all just sat through a practice final, right? So you could go onto Copilot with each question, type it in, and say, give me a question like this, and it'll do it for you, right? You can even go further. You can even go further to say, solve this question for me, right? So let's say I want to solve this for side C. Make it up. Say I'm going to solve for side B. Right? It can actually do it for you and get you out the answer, which for some reason I'm not seeing right here right now, but it can do it. All right. Also, it can show you step by step how to do it as well, right? Like show me step by step how to answer this question. Basically, you just talk to it like a human and it just does it. This is a way for you to study, all right? And it gives you out the answer right there. All right. Use this to create other practice problems that you can study from before your final. All right. You guys know what you need help in. This is the best way to do it. The final will look like what we went over today. All right. So take those questions and say, give me a question like that. All right. It's not going to be any harder than what you saw today. The numbers will probably be just a little bit easier. Like I was saying, that square root 500 thing, I don't think that's going to happen for you. I can't prove it, but I don't think that's going to happen for you. I think it might be like a square root like 25 or something, something reasonable. And that's it. All right. So any other questions? Are we good? Good. All right, let's do this one out real quick. Where was it? Sine B 4/5. Hold on. I'm gonna be lazy. I'm just gonna cut it out. So I'm gonna go a little quick though, because I know you all got stuff to do and we only got like 2 minutes left. But real quick, sine B is equal. Oh shoot, hold on. My fault. Sorry. Forgot to share the screen. Sorry about that. All right, good to go. All right. So we're gonna do this one real quick. Before I do it, Kelvin and Rabosa, I got y'all real quick. This is a QR code. Take your phones out. If you guys didn't get a chance to scan it yet, you could still scan it. Did you get to scan the QR code? All right, so scan that. These are the questions we went over today. All right. So you guys have the PowerPoint and everything. You can use that to help you with the Copilot and all of that. All right. So remember, you want to ask it for new question similar to the one you just answered, right? You can ask it for the answer to that question. You can also ask it for a step-by-step procedure on how to answer the question. All right. Good. All right, real quick. Let's answer this, and then we'll run. We'll boogie. All right. There's supposed to be another leg that we're supposed to see have here, so I'm just gonna write it in. I'm making this up. It's a made up problem, right? We're gonna find leg B. Right? Just making it up. So anyway, sine B is equal to 4/5, right? So remember, I want two triangles. You know what? This is my opportunity right here. We got the orange triangle, and we're gonna have the blue triangle, right? Let's go next, all right? So we got A, B, C. Yo, my fault if anybody's a Pacer fan in here. I'm sorry. I'm just hyped. I'm sorry about that, y'all. All right, so this is gonna be leg A, leg B, and then leg C right here, right? So now we have sine of B. So this is my angle B right here. So what would tell me, where am I gonna put the 4 and the 5? Where? Yeah, so sine B is equal to 4/5, right? So where am I putting the 4 and where am I putting the 5? Is it going to be in the leg A, leg B, or leg C? Go ahead.
The 4 is gonna be B, and then the 5 is gonna be C.
Good. The 4 is going to be in B and the 5 is C. Very good, right? And that's coming from SOHCAHTOA, right? And sine is opposite over hypotenuse. Very good, right? But I need to figure out what that A is. Pythagorean theorem, right? So A squared plus B squared equals C squared. In this case, hold on, let me just scroll down a little bit. In this case, it's going to be A squared plus 4 squared is equal to 5 squared. A squared plus 16, sorry about that, is equal to 25. Subtract 16 from both sides. Let's see what I have. This is going to be A squared is equal to, what's that, 9? 9. Then I want to square root both sides. So A is equal to 3. And there you go. So now my similar triangle right here. This is triangle A, triangle B, triangle C, right triangle right here. This is going to be leg B, leg A, leg C, right? And I know that A is equal to 3. And I'm looking for B, right? I'm looking for B. So what am I going to do, right? I'm going to do orange B over A is equal to blue B over A. Just plug in the numbers, all right? So what is this going to be? 4/3 is equal to B over 3. All right? Did I get that right? Yeah. And then after this, cross multiply. Keep it simple. Cross multiply. Bam, bam. Right? So 4 times 3 equals 3 times B. Right? So 12 is equal to 3B. Divide by 3, divide by 3. So B is equal to 4. And that's my answer to the whole question right there. B is equal to 4 right here. So what do you think? Was that doable? Was that good? Same process all the time. All right. Same thing. As long as you use a similar triangle, you're good. You use the same triangle, That's gonna be hard, especially if you're not allowed to use calculators. Mhm. So we are 4 minutes over time. You guys are good to go. I heard there's a 2 o'clock session, so if you guys want to grab some lunch and then go wherever that class is, you can. Tutoring is open and be open till 8 o'clock tonight. All right. Is it cool if I stop sharing? I want to start the download so I can send that email out to y'all. All right. You got everything or are you still copying? You good? All right. 136 it is? The room? Okay, got you. All right. Awesome. All right. So that's it, everybody. Good luck on finals. Talk to y'all soon.